What's up, everyone, and welcome back to Tech Curiosity Stream. It's great to have you here today. If you're new to the channel, this is the place where we break down complex tech topics into simple, understandable pieces. We dive deep into the stuff that powers our digital world, but we do it in a way that anyone can follow along. Before we jump into today's fascinating topic, I want to ask you a small favor. If you enjoy content that feeds your curiosity about technology, please take a moment to hit that subscribe button down below. And don't forget to ring the notification bell next to it. Now, let's get straight to it. Have you ever wondered how massive companies like Netflix, Spotify, or even your favorite online game manage to run so smoothly all the time? Think about it. They have millions of users accessing their services simultaneously from all corners of the globe. They are constantly updating their apps, adding new features, and fixing bugs without causing major shutdowns or disruptions. It's an incredibly complex dance of servers, databases, networks, and software, all working in perfect harmony. So, what is this game-changing concept I'm talking about? It's called Infrastructure as Code, or IaC for short. Don't let the name intimidate you. The core idea is actually quite simple and elegant. In this video, we are going to spend the next 15 minutes mastering the fundamentals of IaC. My goal is to take you from zero to hero. Think about baking a cake. The old manual way is like trying to bake a complex, multi-layered cake from memory. You might get it right once, but if you have to bake 10 identical cakes, you're bound to forget an ingredient. Infrastructure as code, on the other hand, is like having a perfect, detailed recipe. This recipe is written down in a clear, precise language. It lists every single ingredient down to the gram, every temperature setting, and every step in the exact order. Anyone can pick up this recipe, follow it, and produce the exact same perfect cake every single time. It doesn't matter if you bake it today, tomorrow, or a year from now. The result is always consistent and predictable. In the world of tech, this recipe is a set of configuration files. Instead of manually clicking through menus to set up a server, you write code that describes exactly what you want that server to look like. This code defines everything. It specifies the type of virtual server you need, what operating system it should run, how much memory and storage it should have, what software needs to be installed, and how it should be connected to the network. You write down the desired end state of your infrastructure in a text file. For example, your code might say, I need 5 web servers. They should all be running Ubuntu Linux, have 8 gigabytes of RAM, and have my web application software installed. Alright, to truly appreciate the magic of infrastructure as code, we first need to take a quick trip back in time. Let's imagine a world before IaC became the standard, a time not too long ago, maybe 10 or 15 years. Picture this. A company wants to launch a new website. An engineer, let's call him Alex, would have to physically go into a cold, noisy data center. Alex had to set up not just one server, but maybe 10 of them to handle the expected traffic. He had to repeat this manual process for every single one. Can you imagine the pressure? He has to make sure every click, every command, every configuration setting is identical across all 10 machines. This phenomenon was so common it even had a name: configuration drift. Over time, each server would become slightly different from the others, like snowflakes, but not in a good way. The old imperative way is like giving a taxi driver turn-by-turn directions to get to your destination. You have to say, okay, drive forward 2 blocks, now turn left, go straight for 1 mile, then take the 3rd exit on the roundabout. You are responsible for every single step. The new declarative approach of IaC is completely different. It's like getting into a self-driving car and simply telling it your destination address. You just say, take me to 123 Main Street. You don't care about the specific turns it takes, the traffic it avoids, or the route it chooses. You have declared your desired outcome, and you trust the system to figure out the best way to get you there. This is exactly how tools like Terraform or CloudFormation work. Now that we understand the core philosophy behind infrastructure as code, let's meet some of the star players. You'll hear a few key names thrown around a lot in the IaC space, and the most prominent one is Terraform. Developed by a company called HashiCorp, Terraform has become something of an industry standard. Think of Terraform as a universal translator for cloud infrastructure. It speaks the language of all the major cloud providers, whether it's Amazon Web Services, Google Cloud, Microsoft Azure, or many others. Another major tool you'll encounter is Ansible. While Terraform is primarily focused on provisioning the core infrastructure, the servers, networks, and databases, Ansible often excels at configuring what goes on inside those servers after they've been created. Think of it this way. Terraform builds the house, and Ansible furnishes it. Of course, the big cloud providers have their own native IaC tools as well. For Amazon Web Services, the heavyweight champion is AWS CloudFormation. With CloudFormation, you define your entire AWS infrastructure in a template file written in either JSON or YML. So you have these different tools, and they sometimes have overlapping capabilities, which can be a bit confusing at first. The key takeaway isn't to memorize every feature of every tool. Instead, it's to understand that there is a rich ecosystem of tools designed to solve these problems. So, what actually happens when you hit enter and tell a tool like Terraform to apply your code? Let's walk through the process step by step, from your text editor to a fully functioning cloud environment. It all starts with you, the engineer, writing your infrastructure definition in a simple text file. You save this file, typically with a special extension like TF for Terraform, and you commit it to a version control system like Git. This is the code part of infrastructure as code. The next step is what's often called a plan or preview phase. Before making any actual changes to your live environment, the IaC tool performs a dry run. It reads your code and connects to your cloud provider's API to inspect the current state of your infrastructure. The tool generates an execution plan that details exactly what it will do to make the actual state match your desired state. It might say, I will create 2 new web servers. I will modify one database to increase its storage, and I will delete one old unused firewall rule. This plan is your safety net. This preview step is absolutely critical. It gives you and your team a chance to review the proposed changes before they are executed. It's like a pilot going through a pre-flight checklist. You confirm everything is in order before taking off. Once you approve the plan, the apply or execute phase begins. The IaC tool takes the execution plan it generated and starts making a series of authenticated API calls to your cloud provider, instructing it to carry out the actions from the plan. So we've seen how IaC works, but let's talk about the real-world impact. The first and most obvious superpower is incredible speed. Think back to our story about Alex the engineer who had to manually set up servers. That process could take days or even weeks. With infrastructure as code, you can provision an entire complex production environment in a matter of minutes. Imagine a what-if scenario. Your e-commerce website is about to have its biggest sale of the year, like Black Friday. You anticipate a massive surge in traffic, 10 times your normal volume. With IaC, this becomes a trivial task. You can simply change a single number in your code, say from server count equals 10 to server count equals 100, and run your script. Within minutes, your scaled-up infrastructure is ready to handle the flood of customers. The second major benefit, which goes hand in hand with speed, is unwavering reliability and consistency. Since your infrastructure is defined in a single version-controlled source of truth, your code, every environment you create from that code is a perfect, identical replica. Your development environment, your testing environment, and your production environment will all match perfectly. This means the age-old excuse from developers, well, it worked on my machine, becomes a thing of the past. When every server in your fleet is identical, managing them becomes incredibly simple. If a server ever misbehaves or crashes, you don't waste hours troubleshooting it. The solution is often to just terminate the faulty server and let your IaC automation spin up a fresh, new, perfectly configured replacement. This concept is often called immutable infrastructure. Beyond just speed and consistency for the machines, infrastructure as code fundamentally transforms how human teams work together. By treating your infrastructure blueprint as code, you unlock all the powerful collaboration workflows that software developers have been using for decades. The code is stored in a shared repository like GitHub or GitLab, where everyone on the team can see it, contribute to it, and understand it. This transparency breaks down the walls between development, operations, and security teams. Let's say a network engineer needs to add a new firewall rule for security. Instead of logging into a system and making a change that no one else knows about, they update the relevant IaC file and submit a pull request. The rest of the team can then review the proposed code, ask questions, suggest improvements, and discuss the potential impact. This collaborative review process directly leads to massive risk reduction. The plan or preview phase we talked about acts as a critical safety net. Before any command is executed, everyone can see exactly what will be added, modified, or most importantly, destroyed. This prevents the classic oops moment, where an engineer accidentally deletes the production database because of a typo in a command. Finally, this system empowers teams to recover from failure almost instantly. If a new change causes an unexpected problem, the solution is simple and calm. You just revert the change in your code repository and rerun your automation. The IaC tool will then automatically roll the infrastructure back to its last known good state. Of course, as with any powerful technology, adopting infrastructure as code isn't always a simple walk in the park. It's a significant shift in thinking and tooling, and it comes with its own set of challenges that teams need to navigate. The first and most prominent hurdle is the learning curve. Engineers who are used to clicking through a graphical user interface in a cloud console now need to learn a new domain-specific language like HCL for Terraform or the syntax of YAML for Ansible. It's not just about learning syntax, it's about learning a new, declarative way of thinking about infrastructure. Another significant challenge is the initial time investment required to get started. Migrating an existing manually managed infrastructure to be fully controlled by IaC is not an overnight task. So knowing these challenges exist, how can you and your team get started with infrastructure as code smoothly and set yourselves up for success? The most important tip is to start small. Don't try to boil the ocean by attempting to convert your entire complex production environment to code all at once. Another key piece of advice is to invest in team training and collaboration from day one. Don't just assign the IaC project to one person and expect them to figure it all out. Instead, make learning a team effort. Organize lunch and learn sessions, work through tutorials together, and encourage pair programming. It's also crucial to establish clear standards and conventions early on. Before you write too much code, your team should agree on a consistent style guide. This includes things like naming conventions for your resources, how you structure your code files and directories, and how you will manage variables and secrets. To really bring home the power of infrastructure as code, let's look at how it's used by some of the biggest companies in the world. There is perhaps no better example of IaC at a massive scale than Netflix. Think about the sheer size of their operation. They serve video streams to over 200 million subscribers across the globe, all at the same time. Their infrastructure needs to be incredibly resilient, scalable, and able to handle enormous, unpredictable spikes in traffic. To manage this complexity, Netflix relies heavily on IaC and automation. By moving to the cloud and defining their infrastructure with code, they could design a system with no single point of failure. When they need to deploy a new version of a service, they don't update existing servers. Instead, their automation pipeline, driven by IaC templates, builds a whole new set of servers with the new code already installed. Once these new servers are tested and confirmed to be healthy, traffic is seamlessly shifted over to them, and the old servers are simply terminated. The benefits of infrastructure as code aren't just for streaming giants like Netflix. Companies across every industry are using it to solve real problems. Let's take a look at the world of e-commerce. With IaC, they can write code that automatically scales their infrastructure up to handle the massive influx of shoppers the moment a sale begins, and then scales it back down the moment it ends. Companies that run massive multiplayer online games have to provide a low-latency, highly available experience for players all over the world. Gaming companies use infrastructure as code to deploy their game servers in data centers that are geographically close to their players, reducing lag and improving the gameplay experience. Even in more traditional sectors like finance and healthcare, IaC is making a huge impact. By defining the infrastructure in code, these companies can enforce security policies automatically. The code itself can be audited to prove to regulators that all systems are configured according to compliance standards. So we've taken quite a journey over the last 15 minutes. We traveled back in time to the chaotic days of manual server configuration. We demystified infrastructure as code using simple analogies like recipes and self-driving cars, and we peeked under the hood at powerful tools like Terraform and Ansible. We saw how this approach delivers the superpowers of speed and consistency, turning weeks of work into minutes and eliminating the dreaded problem of configuration drift. We also explored how IaC transforms human collaboration, breaking down team silos and introducing safety nets. It's clear that IaC is more than just a new buzzword. It's a fundamental shift in how we build and manage the digital world. What we're seeing is the logical evolution of technology. Just as assembly lines revolutionized manufacturing and software ate the world, automation is now transforming the very foundation upon which that software runs. As technology continues to accelerate, the complexity of our systems will only grow. The ability to manage that complexity efficiently and reliably will be the key differentiator between companies that thrive and those that fall behind. Understanding infrastructure as code is no longer just a niche skill for a few operations engineers. It's becoming a core competency for anyone involved in building modern technology. Whether you're a developer, a system administrator, or a tech leader, embracing this codified approach to infrastructure is essential for building the future. It's the key to unlocking speed, ensuring stability, and ultimately delivering more value to the world through technology. And that wraps up our deep dive into infrastructure as code. I hope you now have a solid understanding of what it is and why it's such a game changer. If you found this video helpful and it sparked your curiosity, please do me a huge favor and hit that like button and subscribe to Tech Curiosity Stream if you haven't already. Don't forget to ring that notification bell so you won't miss our next exploration into the fascinating world of tech. Thanks for watching, and I'll see you in the next video. Until then, stay curious.